When I'm 3D printing, I make a lot of mistakes, but that's how I learn. Between designing physical parts and learning about slicers and filaments, it's hard at first. I mean, it still is in some ways, but at least I'm breaking stuff less frequently. But that's additive manufacturing, where you build up layers of plastic to make a part. Machining kind of flips that on its head, and I've never done it before. I mean, unless you count cutting holes in a Game Gear on a drill press. I've avoided learning CNC machining because it seems harder than 3D printing and probably a little more dangerous. But Makera said their Z1 is made for people new to CNC who might want to work with materials other than plastic, like me. You see, I got a problem. My goal by the end of this video is to make this out of metal. Now, this is a little spacer I built to mount Intel Xserves in my rack. You see, I only had one set of these, but I needed two. Without these, the whole load of the server goes into the screw heads, and that's not great. The spacers distribute the load better, and line up the rack rails when you're installing the server. Is this a weird design? Yes, that's Apple for you. But I designed and printed these using ASA with 100% infill, which means they're solid plastic, and they're pretty strong as far as 3D prints go. But crank down a screw with 100 pounds of torque, and this weak part up top just kind of rips. I've wanted to make these out of metal, and before I take you on my journey learning CAM, breaking apart, and ultimately machining this thing myself, I figured I'd visit someone with a lot more experience up in Canada.
I'm Sean Hodgins, that's my channel, and I've got a crazy shop, and we just filmed a cool thing upstairs. I need to open the file.
I even have a folder on here.
Yeah, like you can actually see the toolpaths,
Mm-hmm.
and you can position like the tool where it needs to go, and you'll actually see the tool on the screen. Guess we should get our safety glasses on now that we've done some work. So right now we're setting this, and we're actually going to cut the material out of this top piece. It's just going to home all the tooling. So once we start this, the machine's just going to do its thing. It's going to run through the G code, which tells the machine where to go, what tools to fetch, do all that stuff. So basically in any procedure, you need to take off like the rough material, and that'll just give you a really accurate.
Nice and flat.
Yeah, you'll get a good reference because you know where the bottom of the tool actually is.
Yeah.
This is just drilling a spot drill, which is like a more rigid regular drill. And that lets you start the hole before you put the actual drill into it.
So you don't have to mess up your more precise bit?
Because the other drill's long. So once you touch into the tool, it could walk millimeters even, and then you're off. It's not too bad. Drilling is a pretty quick way to like remove material. And then you can, you know, if you have a hole and you need to mill it out, it's nicer on your end mill to not have material in the very middle.
Yeah.
Because the very middle of an end mill is barely spinning. Right? So it's almost not moving at all the closer you get to the machine. This is a 2-flute end mill, which is good for aluminum. You'll probably do a lot of reading about feeds and speeds, but maybe Makera has like things for their tooling already that they know.
Yeah.
Because there's so many different things, like how deep of a cut, how fast you spin the tool, and how quickly you move that tool into the material. But this should totally be doable on the Makera. So those were just roughing passes, and then I do a quick, you heard it speed up a little, now it's doing like a bit of a finishing pass. And also the first time you start machining, you're going to be hovering over the E-stop button or the stop button, just like, I look more relaxed than if I was doing something I hadn't done before. So we're doing another tool change. This time it's a smaller end mill. This is for the little holes that we drilled.
Yeah.
It's just gonna open them up like maybe 0.5 millimeter because of the design. So I drilled a 4 millimeter, and these are just slightly bigger. So the smaller the bit, the more careful you have to be with each pass. That's it. That's one side.
Nice.
We'll dry it off. You can have the part in there. It's one half of the finished part. So now we're going to flip it over this way, and we're going to take the rest of this material off.
Are you holding the doors because they fly open sometimes and shoot stuff out at you?
No, but I like how this says replace windows every 2 years.
Oh.
I don't think that's been done. And there's no date, so.
It'd be funny if after I make this video, some Apple guy is like, yeah, we actually CNC'd all those by hand because we only made like 12,000 of them. And
then one last chamfer. Well, there's some things I'd still change on it, but got a part and the little nub.
Yeah.
That makes 3D printing really difficult.
So I have a few questions. Do you think that the first time I try making one of these, I will accomplish that task, or do you think I'll have a little failure first?
I think if you follow like the steps and you're careful and you use their feeds and things like that, you could probably do one first try if you know what you're doing. But there's a really good chance you won't.
Yeah. What do you think is the most important thing for somebody that's new to machining anything?
Definitely, like I said, being really conservative on the speeds and like feeds and things like that. I guess accepting that you're gonna break bits and you have a lot. The funny thing with machining is any machine you buy, it's like, oh yeah, I bought the machine, now you have to pay the same amount for all the tools you need. So like, you have to keep that in mind anytime you're looking to get something, but obviously that's not like a hard and set rule. But something like this, you're gonna end up spending money on the tools and you have to be willing to break them. I think that's pretty good advice, especially the whole you're gonna spend more on the tools and stuff than the machine itself. Probably even more so with CNC than like 3D printers. Now I'm posting the full interview with Sean over on my second channel, and we even get into how he milled his More token, so go check that out. And subscribe to Sean too, I can't recommend his channel enough. Before I get into making my own version of the Xserve spacer, I figured I'd start with one of Makera's tutorials, but before that, I need to set this thing up. I unboxed it and put everything in this rolling cart. The Z1 fits almost perfectly, though if I'm being honest, I wish I had a little more space on the desktop. Apparently Makera sent over their Kickstarter Ultimate bundle, like their top-end setup that costs like 2,000 bucks. But you can get into a Z1 for closer to half that if you don't need things like the 4th axis, laser, vacuum bed, 3D probe vise, and everything else they sent here. Once I plugged the Z1 into the wall, I checked idle power draw. Using my smart outlets and Home Assistant, I measured about 36 watts for the Z1 and 2.4 watts for the Cyclone. This is a vacuum the Z1 can control to clean up chips during cutting. You can also use it to suck up debris after a job. I was going to use my shop vac, but I'm glad I don't have to. This thing is a little quieter, but more importantly, it's built for this machine. Using G-code, the Z1 can turn it on and off during a job. The idle power draw on the Z1 is a bit high for my liking, so I'm glad I put these things on smart outlets. That way I can switch them off when a job's done without having to touch the machines and not be wasting extra power while they're doing nothing. Now that it's on though, I opened up Makera Studio on my framework, and apparently this puts together what used to be 2 apps, so I can set up toolpaths and control the Z1 in one app. The best thing is, I was expecting to have to tie my printer to some cloud service, but that's not the case. Unlike Bamboo, the Z1 only works locally. I can either connect to its built-in Wi-Fi or plug in through USB and control the printer. I think Bluetooth might even work too, but the good news is you don't have to send your parts through Makera Cloud or anything like that. I guess the bad news is, it's insane I even have to mention that. That should be the default for everything, and it is on here, so good on Makera for that. And they even let you use it with any control software too, like I could use Fusion instead of Makera Studio if I want. Anyway, I saw there was a firmware update, so I ran that, which took a few minutes, and then the printer was just kind of sitting there locked up. So I had to hard cut power to get it to reboot, which was a little odd, but that's okay. And I was going to start the tutorial, but I noticed the cable bundle up here was really tight. Like, there was no slack at all. And I know from my 3D printer building, you can get some interesting failure modes when you stretch cable bundles too much. So I asked Makera about this, and they told me how to remove the back panel to get some more slack. While I'm back here, I'll give you a closer look inside. It looks like there's a power supply, a spindle motor control board, and an MCU that runs everything, along with a few stepper motor controllers. And since I'm into microcontrollers, I took a closer look at the MCU on here. It's the NXP LPC 1768 FB-D100. And that's a mouthful, but it's an ARM Cortex-M3 MCU, and it works in tandem with an ESP32 that's buried on the side for wireless access.
On the back side of the rear panel is a fan that's not super quiet, but it does keep things cool. Anyway, I pushed some extra cable into the cable chain, and now there's a little slack. While I was doing that, I noticed the cover behind the spindle came cracked, probably because the cables were tugging on it so hard. So again, I emailed Makera, and they sent this replacement cowling. But hopefully this was just an isolated thing. I hope this doesn't happen to any of you if you buy this thing. Anyway, since we're inside, let's take a quick look at everything else in here. There's a big spindle with a blower on top that filters the air and clears out chips while you're cutting. The bed comes with this thing called a spoil board, which is like a sacrificial bed for cutting into and holding workpieces. In the back corner of the bed is this little post the machine uses to check tool height in the Z-axis. All the rails had some grease on them and even some protection like this dust cover to help prevent chips from getting everywhere. There's a camera in here, which is actually decent for spot checking things, but I didn't find myself using it much, because like Sean said, I was hovering over the e-stop button for my first jobs. There's a little GPIO connector or something back in the back near this chip blowing hose thing, and that's kind of the basics of the inside. Oh, and when you open up the cover, it makes this cute little ping sound. Here, I'll let you hear what that sounds like. Before I ran my first job, I wanted to see how much power the vacuum would use full tilt, so I manually ramped it up to 100%. That used about 140 watts. So if you're running the whole setup, I'd budget for between 40 and 300 or 400 watts total. Looking at other videos on desktop CNCs, I know one of the most important things is to secure your workpiece. And for Makera's first tutorial, the material they recommend is 6061 aluminum. They ship a 5mm chunk of it, and you can mill out an extra top clamp. Top clamps are these things. You screw them into the bed to clamp down your material. And more is usually better. You don't want your workpiece moving around. On Makerables, that's Makera's printables-like site, but for CNCs, they even give you a picture of how everything should look, which is very helpful for a CNC noob like me. Anyway, after a little confusion over how to set up the job in Makera Studio, I finally got the job started. I set it up to turn on the blower, turn on the vacuum, and even try to blow the bed clean at the end of the job. The Z1 includes a little laser probe, which does two helpful things. First, it'll trace the outline of your job so you can make sure you're in the right ballpark and not going to dig right into one of the screws. Second, it can probe the height of the material you're machining. And like 3D print bed leveling, that's helpful to keep everything aligned in your job. Unlike 3D printing though, where you probe the bed height and work up from there, it seems like with most CNC you probe the top of the material and then work down. Anyway, this job should be simple. It only requires the laser probe and the standard 3.175mm end mill bit that comes with every Z1. But I came prepared for harder jobs too. I found this 3D print on printables that lets me put all the tools for a given job in order. The Z1 doesn't have an automated tool changer like Sean's Tormach, so keeping things organized should help me on longer jobs, at least hopefully. But the job started, and while it was going, I started measuring. I pulled out my decibel meter and found the machine wasn't actually too bad, around 65 to 70 dBA while everything was running. And power-wise, the spindle power draw goes up and down a little while it's cutting, but it averaged around 70 watts while the vacuum was pulling around 100. So not too bad. I could even run small jobs off battery power if I really need to. And not having to run a pump and coolant means the machine can be a lot smaller, but the air didn't do quite as much as I thought it would initially. The air cleaning at the end just kind of moves around chips, so I think I'll just leave that off in the future. I popped open the cover, sucked out as much as I could with the hose from the vacuum, and pulled out the chunk of aluminum. It was a little unnerving having a tool cut right into the spoil board, but I guess that's what it's there for. To get the clamp out of here, there are a few tabs that are left, and I needed to saw those things off. Makera supplies a 4-in-1 tool, and it's not ideal. Kind of the poster child for jack of all trades, master of none. But my goal was to do everything by the book, and it does work. It's just one of the most frustrating little jab saws I've ever used. The file was a little better because it actually locks in, unlike the floppy hacksaw blade. And in the end, I had this basic but serviceable extra top clamp. I tested the top clamp on the aluminum, and it works well, keeping things nice and tight. For that tutorial, Makera gives you an NC file. That has the G-code that tells the printer every little move and thing to do. But for real jobs, like with my own design for this rack mount spacer, I was going to have to learn CAM. That's Computer Aided Manufacturing, and it's how you translate a design, the 3D printer spacer that I made in Fusion, into G-code so the CNC knows what to do and when to change tools. And I wanted to do this on my main workstation, so I installed Makera Studio on my Mac. When I opened it, I saw this Intel warning, so hopefully they'll update it soon, otherwise it won't run on future Macs. But I also noticed this little registration pop-up. I don't love that you have to register just to use the software, but we'll see how that goes. The nice thing is I already model stuff in Fusion, and apparently I could run the CNC through there too if I wanted to skip Makera software entirely. Not that Fusion is any more open or anything, but at least the machine's not tied down to one piece of software. But over in Fusion, I exported my design as a step file. That way the CAM software can see all the surfaces. Then I got to work, and I quickly realized this is a lot more involved than like 3D printer slicing. With modern slicers like Orca Slicer, slicing is nearly automatic, especially since I'm usually just printing one filament with one extruder. With CAM, at least with accurate milling like I'm doing, I have to set up every single tool and toolpath. And that means knowing your model, knowing what kind of features you're generating, and thinking about the order of operations and the way it's being cut. Because you can't just plunge a mill all the way down to your part, you have to remove material to get there. This was honestly a little daunting, and in the process I figured out that even the way I design in CAD has to change if I'm going to mill something versus 3D print it. Because like I had these chamfers in Fusion, and that's fine when you're doing a 3D model, but chamfering is actually an entire separate bit and toolpath in CAM. So I actually went back into Fusion and slightly redesigned my model. After I took out all the chamfers and fixed a couple other flaws, I put the step file back in Makera Studio and got to work. Especially since this was my first time ever setting up a CNC job, the process was basically me thinking through every step of the process, picking a tool, picking an operation, tweaking some parameters, using the 3D view to make sure the tool was doing what I expected, and then rinse and repeat. And for the most part, Makera Studio didn't fight me, but it was a slight bit buggy with the whole thing even crashing one time when I was trying to modify one of the tool parameters. Luckily, I've learned many a time to save early and often, so it was just a little hiccup. The one thing that I didn't really have a good plan for was the bottom side. This thing has a bump on the bottom and an opening for a magnet, so I'll have to flip the part and mill both sides. Makera Studio has a top and bottom for these types of jobs where you can define a second set of operations. And I did that, but I was just crossing my fingers and hoping the positioning on the bed would just work out for me. But at this point, I had my job ready to go and I had a set of 3 tools picked out. I slid them into my 3D printed tool holder and double checked to make sure I labeled them as tool 1, 2, and 3 in the job, which I did. And now it was time. Except I realized one of the bits didn't come with a bit collar, so I had to squish one on with Makera's bit collar installer. Anyway, with that sorted, I mounted the 10mm aluminum block Makera sent with the printer, and I'm actually glad I have that extra top clamp now. It felt better having 2 clamps holding down the long side instead of just one. I was about to hit run, but noticed there was a second firmware update available. I went ahead and ran that, and it seemed to work, but again, I had to reboot the Z1 a couple times, and then I even had to unplug the USB cable from my laptop, otherwise it kept getting stuck. Once I did that, the firmware update did complete, and the printer rehomed itself, and then I fired off the job. Now, I'm going to speed up a lot of this footage, otherwise this video would be like 2 hours long. But I watched it as it traced an outline of the job, probed the surface, and let me swap in the first tool. This is something I like about this. When it's time for a tool change, the light bar on the front of the spindle shows what number it is, which is useful if you're running this without a laptop nearby. But I put in the flat end mill and hit the button on the front of the Z1 to start the job. The first thing it does for every tool change is measures the Z height for the tool by tapping it on the little sensor. Then, well, it goes to town. The first cut was a pocket cut, where it was just cutting down to the top of the part and making the top surface of the part flat. After that, I cut another pocket to the next top surface. I was a little worried about chip buildup, that maybe that'd be a problem, but every time the mill went around, it would clear out another layer of chips, and the air blast seemed to be doing a pretty good job. But it was fascinating watching the display, the G-code, and the machine all running together. Though I was a little jealous of Sean's Tormach, how it could show the position of the bit in real time instead of just jumping from G-code to G-code. The next pass got down to almost the bottom of the spacer, and I got nervous about chips again, so I blew some of them out using my own little air duster. That probably wasn't the smartest thing because the nozzle popped off and got stuck inside the machine. Anyway, once all the facing was done, there were a couple holes to cut, and I plunged right in with the end mill. Like Sean said, it's probably better to drill out the middle first, but besides that jarring sound every time the mill plunges down a millimeter, it wasn't really an issue here. The final face milling started at the top and was just cutting air for a while, so I made a mental note to change that for the next time. That bit was finally done now, and it was time for a little detail cut. I blew out some of the chips using my air duster, which in hindsight, I should probably just use the vacuum for that, or just wait until the end. It's not like they were in the way of anything here. But the part was looking pretty good, so I put in this tiny little end mill to cut a small arrow in the top of the thing. The final thing was a chamfering pass, and holy cow, I did not realize the default settings would cut so deep. So another mental note, make the chamfer a little less aggressive next time. Anyway, my first custom CNC machined part was done, at least the top side. It wasn't looking nearly as good as Sean's, but I flipped over the aluminum, hit the start button, and crossed my fingers the alignment would just be right. It looked right, just eyeballing things off the laser line, so I let the machine go and I noticed the sound was getting a little funky the deeper it went. My dad was at the studio watching with me, and I realized at this point I had forgotten to add little tabs to hold the spacer while I was cutting the backside, so at some point it would probably just fly out, and it did, pretty spectacularly.
Oh, there it goes.
I had my dad hit the E-stop, and it was game over for this part. Now, all in all, this wasn't too bad. I mean, I didn't even break a tool yet, but I made some notes and got to reworking everything for the next job. I tweaked the starting height of one of the cuts to speed things up, I reduced the chamfer depth, and I hopefully set the tabs in the right place so the part won't go flying at the end. And I was confident enough I actually let this job run without watching it the whole time. I mean, I was just one room away so I could hear everything. If something sounded off, I could run in and hit the E-stop really quick. But with the new settings, everything was looking really good on the top side. Even the chamfer looked nice this time. Keeping it a little shallower meant the bit wasn't chattering along the whole edge and making those little scrapes. And this time I put the part on the bed right in the middle of the aluminum, hoping it would make alignment easier on the flip, but it was definitely still off a little. It's like there's a 1 or 1.5 millimeter offset between the front and the back. That's something I'll have to figure out and dial in for future jobs. But this time you can see these 4 tabs holding things together, and that meant this part didn't go flying at the end. But I realized I didn't set up a pass over this raised part over here. That needs to be faced off so the hole from the top side goes all the way through. Luckily, I could just stop the job at that point and add in that facing operation. I wish it were actually easier to stop a job and reset without having to turn off the whole machine and turn it back on. Anyway, I got that facing done, and I had one last operation, the chamfer on the cage nut bump. Now, is this thing perfect? No. I still have a lot of learning to do, but hopefully it's at least functional. I cut out the spacer, and this time I used my little Temu belt sander. This thing is honestly kind of scary. It gets the job done, but make sure you count your fingers after you use one of these things. Lining it up with my 3D print and with Sean's spacer, it's obvious which thing is which, but honestly, for something this small, the Z1 is perfectly adequate, even for a first-timer like me. But now it comes to it. I took out the middle Xserve so I could swap out the plastic spacers, and I found that actually the misalignment on my own spacer saved me from my own bad design. I remembered now that I had made the cage nut bump a little too big, and that actually made the plastic problems worse because it put more stress on the top of the spacers. So when I installed my spacer over on the left, it fit in perfectly flush with the rail. But Sean's spacers, since he machined my file more accurately, they actually catch the edge a little bit. But since they're metal instead of plastic, that doesn't really cause any issue, it just adds a little extra pressure. So I went ahead and replaced all 4 spacers, the 2 in the front and the 2 in the back, and then I reinstalled the Xserve. Now all 3 Xserves have solid mounting hardware, and even though the plastic could have worked long term, I'm glad it's all metal now. I learned 2 lessons through this project. First, there are probably 10 million things people do in this world, like machining, that are way more complex than they look in YouTube videos. Every time I try something new, I gain a new appreciation for masters of the craft. But second, desktop CNC is a thing now, and there will be more makers, tinkers, and inventors who have access to it thanks to this machine. Is it perfect? Definitely not. But honestly, most of the frustrating parts were in the CAM process where I was setting up the job. And software can get better without having to buy new hardware. And before I close out this video, I want to give a special thanks to whoever this Jason guy is at Makera. He has a bunch of videos up that explain almost every aspect of beginner CNC, and they're all quick and to the point. Until next time, I'm Jeff Geerling.